Lab 3, black hole, Paige Mayfield. To introduce it, we set up with the star mass given, and a star is orbiting a black hole with an unknown mass. The black hole is located at the origin, and the starter code will be used to create a unique position vector values for the star. In this experiment, we will find the starter code in GlowScript and create a model of the motion of the star. We will find the net force of every position on the star, the parallel and perpendicular one. We will find the mass of the black hole. The initial conditions. The system is the star. The surroundings are the black hole. The time between data points is 1 Earth day, which calculates to be this amount of seconds. And assumptions being made are the only force acting upon the star is a black hole. The time between observed position vector values is equal to 1 day, which is 86,400 seconds. The physics principles used are Newton's second law with F net equal dp over dt, F net equal to F net parallel plus F net perpendicular, and then momentum, P is equal to M times V, and delta P is equal to PF minus PI. And then we used Newton's universal law of gravitation, which is the absolute value of F gravity is equal to G times capital M times lowercase m over the absolute value of R squared. This is the computational model where we created the unique position of the data and entered the initial position conditions. And then we calculated the change in momentum and the F net of delta P over delta T. And in this computational model, we calculated the F net parallel and the F net perpendicular, and we calculated the mass of the black hole. Here we set the arrow scale, created the arrows to represent each force, and advanced the time. And here is a link to the model. And the orange arrow represents the F net. The blue arrow represents F net parallel. The purple arrow represents F net perpendicular. And the mass of the black hole was calculated to be this amount in kilograms. The observations of this model were that as the velocity in the F net speeds up as the star approaches the black hole, the F net parallel goes in the positive p hat direction, which is in the direction of motion as it is speeding up. As it is slowing down, it is going in the negative p hat direction. What does it mean? Net force is responsible for causing a change in momentum. When F net is not 0, the velocity is changing, therefore momentum is also changing. According to the equation for momentum principles, F net is equal to delta P dt. The magnitude of the net force and the change in momentum are equal. So mathematically, the change in momentum is the same as net force. What if? What would happen if the black hole was switched out for another black hole and the star's orbit remained the same? It would be possible to find a new mass. It would be impossible, to find a new mass. In order for the star's motion to remain unchanged, the new mass must be the same because Fg is dependent on the mass of the black hole. Conclusion. Mass of the black hole was found by assuming the net force was equal to the gravitational force of the black hole. Gravitational formula was solved for mass of the black hole. In an alternate experiment, I would use more positive vectors and smaller timestamps to create a more accurate model and better predictions, and possible errors could be that the time sections were too large and the calculations were unable to be made precisely. Thank you.